All right. Hello, all. Welcome to another online causal inference seminar. Today we have a talk by Caleb Miles from Columbia University on two fundamental problems in causal mediation and analysis. So today our discussants are going to be Jamie Robbins from Harvard and Thomas Richardson from University of Washington. We will be switching back to our standard format, so there will be a discussion with slides after the talk. And the questions today will be handled by Dominic, so I'll let him take over that.
Sure. As usual, please submit your questions via Q&A. There's a button at the bottom. Caleb has 2 points at which he will stop and take questions, so please submit them as early as you have them. Thank you. Without further ado, Caleb, feel free to get started.
Great. Thank you very much. I'm finding my slides. Okay. Yeah, thank you. So, I want to thank the organizers of the online causal inference seminar for, especially Emma, for inviting me to present. I've been enjoying these talks, since kind of early in the throes of the pandemic, and also want to thank Jamie and Thomas very much for agreeing to be discussants. Like probably most of the audience, I really admire both of your work. And so I'm excited to hear what you have to say. So the title of my talk is Two Fundamental Problems in Causal Mediation Analysis. And perhaps a bit unwisely, I decided to try to cram 2 talks into one. The reason being is the first part I've already presented on quite a few times, and I didn't want people to get bored, so I want to talk about something new, but I also wanted to talk about something that I actually have a manuscript for. So the second part, kind of a work in progress, but eager to hear people's thoughts. Both parts are very conceptual. I'm not really talking much at all about estimation, mostly just identification and interpretation. Okay, so roadmap for the talk. I'm going to start with a brief background on mediation, just for those who don't know much about it already. And then in part 1, I'm going to talk about the causal interpretation of randomized interventional indirect effects. And then part 2 will be about the central role of the mediator process in mediation analysis. Okay, so let's start with the background. So in causal inference, right, we're typically interested in whether some exposure A has an effect on some outcome Y. And mediation is addressing a more nuanced question, and it aims to understand the mechanism by which an exposure A affects an outcome Y. In particular, it's supposed that there's some intermediate event, say M, that might be responsible for transmitting part or all of the effect of A on Y, and right, we aim to understand how much of the effect of A on Y is through this channel by affecting M, which goes on to affect Y, versus direct with respect to M. So this is referred to the indirect effect versus the direct effects. So traditional approaches to mediation have simply just defined the indirect effect in terms of coefficients from structural equation models. So for instance, the kind of traditionally most popular way to do this is just to posit linear models for the mediator given the exposure, and then for the outcome given the exposure in mediator, and just defining the indirect effect to be the product of the exposure coefficient in the mediator model with the mediator coefficient in the outcome model. And so, at least intuitively, these are supposed to kind of capture the effect of A on M and the effect of M on Y. And then, so the most straightforward way you could think to estimate this is to just fit OLS for both of these, and then multiply the coefficient estimates together. And this is known as the product method estimator that was popularized by Barron and Kinney. This gets used all the time, especially in kind of social sciences. Given that this is a causal inference seminar, hopefully the limitations of this approach are clear to almost everyone. The first is that there's no clear causal definition here, right? There's no appeal to counterfactuals or interventions of any sort. This doesn't make any attempt to account for confounding, nor have I included any common causes on this DAG. And lastly, this relies on excuse me, linear models with main effect terms only. So this doesn't allow us to account for things like interactions or nonlinearities. If you have like a non-continuous mediator or outcome, you're just meant to model it linearly. Okay, so in 1992, Jamie and Sander Greenland, and then several years later, Pearl, defined direct and indirect effects in terms of counterfactuals. So now we have a real, we have a definition of direct and indirect effects that have a real causal interpretation. Excuse me. And Pearl showed that under certain known observed confounding assumptions, the first three of which are pretty standard, and the fourth I'll talk about more later, then the natural indirect effect is nonparametrically identified. So the nice thing about nonparametric identification is you can just plug in models, and then you get what the identification is in terms of the parameters in those models. So for the linear models I showed earlier, van der Waal and Van Steylant showed that, in fact, the natural indirect effect under these models is equal to this product of coefficients, but we can relax this. We can introduce exposure mediator interaction. We can account for other variable types and other types of models. Okay, so that's it for the background. Okay, so for this part, I'm going to start with, we've already talked a little bit about some history of mediation, but I just want to kind of go back through and think about this through the lens of whether mediation is quote unquote hard or easy. And by that, I mean, how hard or easy is it to find in real world scenarios, cases where it's realistic that the assumptions that you would need to employ these methods are to actually hold. Right, so from the advent of mediation, this is like the path analysis and structural equation modeling framework. This approach is easy in the sense that basically you're not really making any assumptions. Maybe there's a kind of implicit assumption that these statistical models are correctly specified. Then we have the counterfactual formalization of Robinson, Greenland, and Pearl that defined it. That define the natural indirect effect, which I'll give the definition of in a bit. But identification in this case relies on some very strong assumptions, and so mediation became hard. Then came along the idea of the randomized interventional indirect effects. So Jamie was the first, as far as I'm aware, to kind of introduce the idea of this randomized interventional indirect effect, and has been adopted by a number of people, and it has become very, very popular. I think this van der Waal, Van Steylant, and Robbins article has done a lot to popularize this, especially as a means to get around this, strong assumption that I'll talk more about. And so identification of these randomized interventional indirect effects rely on more standard causal assumptions. So mediation is kind of back to being easy again, if we can use this. However, there's been this sort of folk wisdom circulating that randomized interventional indirect effects don't truly capture mediation. And if this is the case, and we're interested in mediation in terms of mechanisms, then we're kind of stuck back with the NIE, and mediation's back to being hard. So I think Thomas is one of the people that I've heard kind of circulating this folk wisdom. And I think maybe Jamie would argue, well, it doesn't really need to be shown. You just kind of look at the definition of randomized interventional indirect effects, and it doesn't have a mediational interpretation. But I think this is kind of really in the milieu, like people really think of these things as having this mediational interpretation. So my goal sort of is to formalize what do we want from a mediational effect measure, an indirect effect measure, and do these effects satisfy such criteria? Okay, so now I'm going to introduce some notation. I'm going to start with this really simple 3-node DAG, and basically for the remainder of the talk, I'm going to assume that we're in a randomized trial setting so that we can, just to keep things as simple as possible, and we don't have to account for some baseline covariates throughout, although things generalize pretty naturally. Okay, so A is going to be our exposure. Suppose it's binary, taking values little a star and little a. And Y is our outcome, and we'll denote our possible mediator with M, measured sometime between A and Y. And then we'll need to define counterfactual versions of Y and M, Y under interventions on both A and M, and then M under interventions on A. And then to talk about mechanisms, we'll also want to talk about nested counterfactuals, which involves just plugging in this M counterfactual into the M inside of the Y counterfactual, where importantly, these A's in the nested counterfactual need not agree. Okay. So now I'll give the definition of the natural indirect effect. This is kind of the canonical causal definition of an indirect effect ever since these, seminal papers by Robinson, Greenland, and Pearl. So it is the contrast between these mean nested counterfactuals, one in which these two exposures agree, and then another in which these two exposures disagree. And this is comparing counterfactual outcomes under two different interventions. The first is setting A to the value little a, and M to the value that it would have taken under an intervention setting A to little a. Or in other words, just the counterfactual Y under an intervention setting A to little a by composition. The second one keeps A set to little a, but now is going to change the mediator to the value it would have taken had A instead been set to little a star, right? And so the sort of direct effect of A is being held constant, whereas the effect through M is what's changing. And so this is why this has this indirect effect interpretation. As I mentioned, identification relies on for ignorability or exchangeability, whatever you like to call it, type assumptions. And the first three are pretty standard. It's the fourth one that really generates the most controversy. And so on an earlier slide, I just wrote this as no component of C is affected by A. This is often how it's kind of stated in English language, but formally, it's this counterfactual independence statement you see here. And this statement has two important implications. The first is that this is what's known as a cross-world counterfactual independence, meaning that these two counterfactuals arise under conflicting interventions, one setting A to little a and another setting A to little a star, that we could never do simultaneously. And so this has important implications for falsifiability. And so, people object to this on kind of philosophical grounds. The second is, I think, a little easier to digest, and that is that this implies that there's no confounder of the effect of M on Y that is itself affected by A. So we can have confounders, say L here, of the effect of M on Y in the natural indirect effect under, cross-world counterfactual independencies will be identified. But if it is affected by A, then the NIE is not identified. Okay, and so there's not really anything we can do in this situation here, because the only way to sort of get rid of this problem is to randomize M, but then we've broken the effect of A on M, which is part of the effect that we're interested in. So to circumvent this fourth assumption, Van der Waal, Van Stalen, and Robbins proposed what they refer to as randomized interventional analog of the NIE, which I'm going to denote with this superscript R here. Again, this idea originally introduced by Jamie has been considered in many forms since then. But basically, it's a very clever idea to get around this assumption, but still get something that very, very closely resembles the NIE. And so here's how it works. So instead of an intervention setting the mediator for an individual to the value that individual would have had we assigned their exposure to be little a prime, they define a new random variable, which I'll write G of a prime, as a random draw from the distribution of M of a prime, such that marginally it has the same exact distribution as M of a prime, but it's independent of M of a prime, and more importantly, it's conditionally independent of Y of AM given A. In other words, it satisfies, it's kind of, it's doing what we wanted M of A star to do, right? So it's satisfying this assumption but we're not using m of a star anymore. We're using g of a star. Then the NIER is defined to be this expression here, which is just exactly the same as the NIE, but replacing the mediator inside of the nested counterfactual with this corresponding g of a and g of a star. So as I said, this very closely resembles the NIE, but because by sort of construction, we've made it satisfy this assumption, this is something that we can identify without making the fourth assumption, which has to do with m of a. Okay, so that leads us to the question, is the NIER really a quote-unquote valid indirect effect measure? And to answer this, first we need to answer the question, what do we mean by a valid indirect effect measure? If so, when is this the case? And if not, is this still a useful quantity? Okay, so let's take a step back and ask ourselves, what is mediation? So this is a quote from the introductory chapter of van der Weel's book on mediation and interaction. He says, the phenomenon whereby a cause affects an intermediate and the change in the intermediate goes on to affect the outcome is what is generally referred to as the phenomenon of mediation. So to define this on an individual level, and to kind of reinterpret, we would say that there is an individual level indirect effect for a given subject if their exposure A affects their mediator M and the resulting change in M affects their outcome Y. So formalizing this for subject I, the first part means that the M counterfactuals differ. And the second part means that the Y counterfactuals differ where M is changing between M and M prime, where these are just the values in the first part, right? The value that is induced, sorry, the change in the mediator that's induced by the change in A. Right, and this needs to hold for at least one of A prime in A star or A. Or equivalently, we can just compose these into a single equation, and that says that these two nested counterfactuals differ for at least one of A prime in A star or A. Okay, so what I'm concerned with these individual direct effects. Well, so in kind of standard causal inference, right, we have this notion of the sharp causal null, which basically says that of exposure on outcome for any subject I. That is, the counterfactuals Y are the same analogous sharp null for the mediational case. So the sharp mediational null, I'm going to define to be the following, that these nested counterfactuals are the same for individuals I for both A prime equals little a and A prime equals little a star. Okay, so from there, right, it's very natural that under the sharp causal null that we would want any measure of the total effect to be 0 whenever the sharp causal null holds. And so likewise, we would like an analogous criterion for mediational effects. So to that end, I define the sharp null criterion. So an indirect effect measure satisfies the sharp null criterion if it is null. So for instance, if we're on the difference scale, it's 0, whenever the mediational sharp null holds. In other words, if there's no individual level indirect effect for anyone in the population, then any indirect effect measure that satisfies this sharp null criterion will be null. So I argue that this is a very reasonable criterion that we would demand of an indirect effect measure if we want it to be interpreted as a measure of a stronger criterion for an indirect effect measure, monotonicity, and that just involves getting the direction. But I
Caleb, can you hear me? I think you're cutting in and out. Maybe you're.
I'm cutting.
Can you turn off your video for now?
Let me
So
check
maybe
my internet connection.
maybe if you turn off video.
I can hear you. Can you hear me?
Yes.
Oh, I can try changing internet connection. Sorry.
Or you just turn off video and maybe like then your kind of audio will be more stable.
I think it's briefly disconnected. Oh, there
Okay.
it is.
Sorry.
Okay.
Is this better?
Currently
We can hear you. Oh, yeah.
Just go on
Okay,
and
let's try. Please continue. We'll see how it goes.
Okay.
Oh,
okay. Well, yeah, I'll proceed. So, I don't know where I started cutting out, so maybe I'll start just from definition. So, an indirect effect measure satisfies the sharp null criterion if it's null whenever the mediational sharp null holds. So, for instance, if we're on the difference scale, it would need to be equal to 0. So in other words, if there's no individual level indirect effect for anyone in the population, then any indirect effect measure that satisfies the sharp null criterion will be null. And so I argue that this is a very reasonable criterion that we might demand of an indirect effect measure if we really want it to have a mediational interpretation. And there are other stronger criteria you could introduce. So for instance, I introduce a monotonicity criterion that is more concerned with getting the directionality of the effect correct, but in the interest of time, I won't talk about that more. And importantly, it's very trivial to show that the natural indirect effect satisfies both of these criteria. So, okay, so I'll pause here for questions if there are any so far.
Thanks. Currently, there are no questions, so this is just a reminder for everyone. Please submit your questions in the Q&A. Thanks.
Great. Okay, so I'll proceed. Okay, so this leads us to the main results of this paper. The first is that the randomized interventional natural indirect effect does not satisfy the sharp null criterion in the presence of an exposure-induced confounder, which is one of the violations of the fourth assumption. And likewise, it does not satisfy the sharp null criterion in the absence of cross-world counterfactual independencies, which is the other implication of the fourth assumption. So I argue then that this means that the NIER doesn't really have a very meaningful mediational interpretation, since it can be non-zero even when there's no mediational effect for anyone in the population. So I'm not going to get into the details of the proof, but they're both proofs by counterexample. In kind of the gist of them is the following. So in both cases, we can construct a counterexample in which for half of the subjects, A has no effect on M. For the other half, M has no effect on Y. And so therefore, there's no one for whom both A affects M and M affects Y. So the mediational sharp null holds. And yet we can show that the NIER in both cases is equal to some expression that's not zero in general, and it's not bounded away from plus or minus 1/4. And this is an example where Y is binary, so that has some meaning. So you may take a look at the example and decide for yourself if this example seems kind of too contrived. To which I would say, that's fair, but if we want to rule it out, then we should be explicit and make further assumptions in order to rule it out. And in fact, there are a number of assumptions that we can make that will do that. I won't get into these here, but in the presence of exposure-induced confounding, we can rule it out. The caveat to that is that under any of these assumptions, the NIE is also going to be identified and equal to the NIER. So the NIER is not really providing any advantage over the NIE. In other words, we might as well just use the NIE. It has a simpler interpretation. Likewise, we can recover satisfaction of the sharp null criterion in the absence of cross-world counterfactual independencies if we don't have exposure-induced confounder. In particular, under the separable effects model introduced by Robbins and Richardson, that corresponds to this extended DAG, where briefly, basically this DAG, if you're not familiar with the sort of separable effects approach, assumes that we can decompose the exposure into two components, O and N, that are deterministically linked with A. So in the observed data, they're the same as A, but we're assuming that one of them, N, has no direct effect on Y with respect to M, and further that O has no effect on M. So under this model, the NIER and the NIE agree, and therefore the NIER can be shown to satisfy the sharp null criterion. But again, the NIE is identified, so we might as well just use it instead, right? Okay, so thus far I've been, I guess, fairly negative. So, I want to clarify, this is not to say that the NIER isn't useful, right? I've just said that it lacks a true indirect effect interpretation. So despite this, the NIER still has a meaningful causal interpretation, in particular as an effect comparing two joint stochastic interventions. So the first intervenes to set A to little a, and then sets M according to a stochastic intervention using the law of the counterfactual mediator under the intervention setting A to little a, and then the second being again setting A to little a, but now using a stochastic intervention setting M according to the distribution of M of A star. So this might be an intervention that you might be, interested in implementing or learning about. A closely related interpretation can be useful when identifying sources of racial disparities when one's concerned about interventions on race not being well defined. So that just involves kind of replacing interventions on A with instead conditioning on A. Okay, so to summarize part one, right, we started with this kind of folk wisdom that randomized interventional indirect effects don't really capture mediation. So I'm arguing here that this is confirmed without further assumptions. The NIER doesn't satisfy this sharp null criterion. Hence, it lacks a true indirect effect interpretation, or at least if you agree with my conceptualization of indirect or mediated effects. So therefore, mediation is kind of back to being hard. The best we can do is partial identification bounds for the NIE. However, the NIER does have a meaningful joint stochastic intervention interpretation. So to me, the kind of big open question here is, okay, the NIER doesn't have a meaningful mediational interpretation without further assumptions. Are there any other non-trivial indirect effect measures that do satisfy the sharp null criterion under weak assumptions relative to NIE? And in fact, this may be partially solved already. So recently, Ivan Diaz proposed new ideas that lead to a measure that does appear to satisfy kind of analogous versions of the sharp null criterion for certain path-specific effects that are not identified. And so one might think that one could so these path-specific effects decompose the natural direct and indirect effect further, which leads one to think that you could kind of put these back together and maybe they will satisfy kind of my mediational sharp null criterion. I think this remains to be seen, but anyway, this is promising work, so stay tuned. If this is the case, then mediation may be kind of easy again, or easy-ish. Okay, so I'll pause there before diving into part two.
Hi, so there are two questions. The first one, does the stochastic intervention also change the research question, different from the standard NIE definition?
Yeah, exactly. I mean, I think that that's part of my point, but I guess so all of this is kind of presupposing that you are interested in mediation in terms of mechanism explaining how A affects Y, right? If that's what you're interested in, the question of whether A affects M and M goes on to affect Y, then I'm arguing that this isn't really addressing that. But the kind of the second part, what I said, it still has meaningful interpretation. it does change the research question to one of, or I guess I'm arguing is that it should be interpreted just as this kind of joint stochastic intervention and not taken further without, at least without further assumptions to have this mediational interpretation.
Okay. So now we have more questions rolling in. I'll take maybe the last one currently here. So the principal stratum direct effect does not have any of these issues?
So yeah, I mean, I think this is something that I need to look into further, but as far as I understand, right, you have the principal stratum direct effect, and likewise you have what's known as a controlled direct effect. But I'm interested in indirect effects. So one way to get an indirect effect is just to subtract these direct effects from the total effect, right? And it's been shown that when you subtract the direct effect, you're not left with, in either case, principal stratum direct effect or controlled direct effect, which with what you're left with is not only a mediational effect, it also involves pure interaction. And so you can have a setup where A has absolutely no effect on M, yet A and M interact in their effect on Y. In which case, what's left over from the principal stratum direct effect, when you subtract it from the total effect, is still going to be non-zero, even though there's clearly no mediation because A has no effect on M. And likewise, this, same thing is easy to see in controlled direct effect. But yeah, there may be some work that tries to address this, but kind of your standard principal stratum direct effect does have the same issue, basically. And I think it's easier to show. I think the NIER is kind of closer to NIE than like the total effect minus principal stratum direct effect.
Cool. Maybe one very quick clarifying question for some. So when one person asked about covariates, how does covariates like sex, age, ethnic group fit into this? It's not considered a mediator because no intervention changes it. If so, how should we think about it? So I think that's just a clarifying question about your setup and how covariates fit into it.
Right. So yeah, so for these sorts of variables, I think that these would not typically be considered as mediators, right? I mean, you would have to have a very primitive exposure that you could maybe reason about affecting these. So generally, we would not consider these to be mediators. These could be considered as exposures. That is controversial because people disagree about whether we can intervene on these, right? And so that's kind of what I was getting at back here without really going into detail here, just in the interest of time. But we can basically define analogous versions of these effects. Then instead of intervening on A, just condition on them. So we don't have to reason about intervening on these things. And of course, they could be considered as, pre-exposure confounders as well. Or, if even if we're in a randomized trial, we need to worry about mediator outcome confounding. So these may be important to control for. So I don't know, hopefully I've addressed this question.
Yep, that was good. I think in the interest of time, we probably want to continue, but
okay, cool.
Maybe at the end you can take more.
Okay, great. Yeah, thanks for the questions.
We have around 10 minutes left, by the way.
Oh, goodness. Okay, so we better get going. Okay, so part 2 is the central role of the mediator process in mediation analysis. So I just want to kind of take a step back and think through the role of time-varying variables in causal inference. So I think, traditionally, kind of when causal inference was first being formalized, things were kept very simple. You had exposure was only really considered if it was, well-defined at a fixed point in time, right? However, of course, there are many exposures that don't behave this way, right? And this has motivated a lot of Jamie's work, starting from the 1986 paper and so on. So there are some exposures that are time-varying, some that are, more point treatment. The outcome typically or traditionally has been defined at some fixed point in time after baseline, which I think is typically for the most part valid and meaningful, although maybe less informative than if we handled it as longitudinal or outcomes. It's kind of optional how you handle that. And then confounders are, typically we need to consider time-varying confounders whenever the exposure is time-varying. So in this part, I want to argue that the mediator plays a different role than the exposure and the outcome, and that it's without strong assumptions, it's kind of less optional whether we consider it to be time-varying or not. In other words, we should always think of it as being time-varying. So, but traditionally how this is handled and how it's handled in probably the vast majority of applications is that it's just considered at a fixed point in time between exposure and outcome. Although, this can be abused. People use cross-sectional data often to do mediation, but we won't do that. But even, so this might be because people only observe it once intermediately, or it could be that people observe it a bunch of times over the course of the study, but they don't know what to do with it. So they just pick a single time point, right? So this is how mediation is often conducted. Now, of course, there are lots of methods being developed for longitudinal mediation with time-varying mediators. Just a small sample of them listed here. But what I want to kind of address here is, are these really needed? I mean, even in the simple case with a fixed time outcome, are these needed, or can we just get away with just using the mediator at a single point in time between exposure, baseline and follow-up? So the main questions are, what are the implications of only considering the mediator at a single time point? When is it reasonable to do this? And when it's not, how should we proceed? So through the rest of this part, just to keep things as simple as possible, I'm going to only consider a point treatment setting with fixed time follow-up. Okay, so recall this fourth assumption, and the main point here is that this assumption rules out this DAG on the right here, where we have confounders of the effect of M on L that are affected by A. But so I want to think about a setting in which, besides the exposure, mediator, and outcome in their corresponding underlying processes, suppose for simplicity, there's no other variables, right? Well, if we're only considering M at a fixed point in time, say time t star, what happens with earlier instances of M? So for instance, take M, halfway between baseline and t star. And for example, consider, maybe this is a smoking cessation trial, and then M is just their smoking status through the duration of the trial, right? Then surely smoking status at an earlier time point, t star by 2, is going to affect smoking status at time t star. And further, if M is truly a mediator, then most likely A is not only affecting M at time t star, but also at time t star by 2. And likewise, M at not only t star is affecting Y, but at the earlier time point is affecting Y as well. So if this is the case, then all three of these arrows are present, and this earlier instance of M is playing exactly the role of L here. This is the same DAG, right? And so this is a phenomenon I'll refer to as mediator autoconfounding. And of course, the same goes for any other time point prior to time t star. Okay, so right under this DAG, we said the NIE isn't identified, right? So what can we do? Do we abandon all hope? Are there some conditions under which the NIE is identified? So in order for it to be identified, we would need at least one of these red arrows to be absent for MT dagger for all T dagger between time 0 and time T star. And I think probably most people would agree that this arrow here is probably generally going to hold, right? So it's the other two arrows that we want to focus on. So a little piece of good news. One of these arrows being absent seems likely to happen under the mediational sharp null when either A has no effect on the mediator process, or the mediator process has no effect on Y for any T. So if we assume that this is the case, we assume the mediational sharp null, then the identification formula will be correct under the sharp null of no effect through the mediator at time T star, and consistent estimators of the identification formula will still go to 0. So in other words, we can still get a consistent test for the natural indirect effect. Okay, but what about the alternative? So this arrow here, from A to M T dagger is going to be absent for all T dagger if A only affects M in a time window that starts at time T star. So this is kind of like dormant time period, right? Where A has no effect on M, only starting at T star. And likewise, M T dagger, this arrow here will be absent for all T dagger if M only affects Y in a time window that starts at time T star. So if we, in the latter constitutes a type of Sutva assumption that for all sample paths, M and M prime of T over this baseline to T star window that agree at time T star, basically you would be assuming that the effect on Y is the same. They only depend on this process via T at T star, right? And so in order to, to guarantee this to hold, you would need to know some very detailed information about the timing at which these effects take place, or at least get very, very lucky and when you happen to observe in that T star. Okay, so if this isn't the case, then what can we do about it, right? So the article from part 1, Van der Waal, Van Silent, and Robbins, gives 3 alternatives when faced with exposure-induced confounding. The first is to instead estimate the randomized interventional analog, which, as you know, in part 1, I showed that this has challenges with interpretation as a true mediated effect. The second is to instead estimate a path-specific effect through M at T star, but not through all M T dagger for T dagger before T star. So this is a path-specific effect only through T star. But this seems quite limiting, right? Because don't we also care about the effects through M prior to T star? The third, I think, is the most promising of these proposed approaches, and that says, consider the joint mediated effect simultaneously through all of the process T up to T dagger. And then, if we have finitely many time points, at least, we can approximate this and just treat this as a multiple mediator problem to get the joint effect through all of these. But I think we would want to take this a step further, because if we're considering the joint mediated effect simultaneously through all of the mediator process up through time T star, why not just consider the full mediated effect through the entire mediator process? In fact, is this not what we really mean when we ask whether the effect of A on Y is mediated by M? So by quote unquote M, I would argue that we mean the full mediator process, of which M measured at T star is only a very coarse measurement. So to distinguish these two effects through the entire process versus at time T star, I'm going to refer to the former as the full NIE with the superscript F, and the latter as a coarsened NIE with a superscript C. And in fact, we can do an analogous path decomposition in terms of the full NIE, just like we could in terms of the coarsened NIE, right? And so I've kind of made a elaborated version of the DAG where now I have the entire mediator process before and after M at T star. And so now the full natural direct effect is going to be the one this in red here with respect to the entire process. And then the full NIE is going to include all of these paths going through any part of the process. And in fact, we can relate this to the coarsened NIE and show that these are distinct quantities. And in fact, the coarsened NIE is but one piece that makes up the full NIE. In fact, we have a path-specific effect decomposition of the full NIE into this guy and then 3 other path-specific effects. So I can talk more about those if people are interested, but for the sake of time, we'll move on. So in many cases, it's probably quite reasonable to assume that all effects in this decomposition are in the same direction. And in fact, if this is the case, then the coarsened NIE will serve as a lower bound in magnitude of the full NIE. So that's a nice result. But of course, the coarsened NIE we said is not identified without further assumptions. But since it likely is identified under the mediational sharp null with respect to the coarsened NIE, we can at least use the coarsened NIE to test for the presence and direction of the full NIE. But unfortunately, we can't say the same thing for the corresponding natural direct effects because the bound is in kind of opposite direction, which is less interesting. Okay, so some parting thoughts from part 2. Basically, I just want to argue that we should start reckoning more seriously with the mediator process whenever we are discussing mediation. When we only observe the mediator at a single time point, we should critically evaluate whether it's likely that the coarsened NIE is actually going to be identified in practice. And to the extent possible, if we're truly interested in mediation, we should try to measure the mediator as frequently as is reasonably possible in order to more directly target the full NIE, and then we can leverage these methods that are being developed. And then lastly, for a very frequently and or irregularly measured mediator, which I think is the ideal case where we measure the mediator very frequently, we may need to adopt techniques from functional data analysis to estimate nuisance parameters that look like function on scalar regressions or scalar on function regressions, as have been proposed in a couple of articles here by Lindquist and Zhang et al., at least. Okay, so I'll stop there. Thank you so much. Part 1 is now in press at JRSSB, and you can access from this archive link here. Part 2 is still a work in progress, so I'd love to hear any thoughts that folks have. And if I don't get to your questions, please feel free to email me after this concludes. And since I guess this is recorded, I can like flash through these so people can pause and read them.
Thank you, Caleb. Great talk. So in the interest of time, we're going to skip to the discussion right away, and hopefully we'll have some time for a back and forth after that. So you can stop sharing your screen, and I'll ask Jamie and or Thomas to start sharing theirs.
So can everyone hear me?
Yes, and
Okay.
we can see the slides as well.
Okay, great.
Looks great.
Okay, so it's I feel it's sort of unfortunate that the name interventional, the interventional approach that was discussed, it was talked about, that Tyler talks about, was called interventional mediation, because I want to talk about a different view of interventional mediation that does satisfy if there's no indirect effect, then we get 0. And so it's really about mediation. Okay, so Caleb had this slide quickly. So the story is, I'm going to give you a story. A is smoking, M is hypertension, Y is heart attack. We assume all heart attacks are after M. And there's a story that this is like a story Pearl gave to justify why we do mediation. But he gave, and he said, suppose, so we're assuming that A affects M only through nicotine. Well, I want to go the other way. And A affects Y only through the non-nicotine components of cigarettes. So A can be decomposed into nicotine and other components of cigarettes with those properties. And now, so the story is we want to know what will, in a year, we're going to have cigarettes without nicotine. And we want to, but today, all cigarettes have nicotine. We want to estimate what we'll see in a year when those, I want to estimate today what we'll see in a year when nicotine is removed from cigarettes. Okay, so so our idea is we're going to think of nicotine and I'll call it tar as intervening on them. So right now we're seeing if you're smoking, we're seeing this guy. You have both nicotine and tar, and or you don't smoke. But we're interested in a year from now when people will have tar but no nicotine. Okay, and so in terms of direct and indirect effects, the direct effect of tar is that, and the indirect effect of nicotine. So one is I fix your tar level, and I compare whether nicotine to non-nicotine, because all the nicotine effect is through M. So that's why. So this is comparing. This is fixing in the comparison this arrow, and we're comparing that pathway. So this is just like mediation. Okay, and so what we're asking is, and also I want to say that in our data, these edges are deterministic, because if A is 1, you're a smoker, and today, that's where our data is, N is 1 and O is 1, and otherwise N is 0 or O is 0 if you're not a smoker. But I want to know what will happen if O is 1 and N is 0. We've taken nicotine out of cigarettes. What will smokers experience then? And that seems impossible because positivity fails. There's no one in the data who did that. But we're going to show you with this structure, you can identify it. Okay, so the direct effect, again, is the effect of smoking nicotine-free cigarettes versus not smoking at all. And the indirect effect here is smoking regular cigarettes versus smoking no nicotine effects. Now, what is the relationship this to the counterfactuals that Caleb was talking about? For example, the natural indirect effect. Well, in the natural direct and natural direct effect, the only interesting problem was this cross-world counterfactual, where we put your M in, as you remember from his talk, when the treatment, for him, the treatment would just be A. When A was 0, you were a non-smoker for M, but you were a smoker on this path. Okay, on this path, you are a smoker. On this path, you are a non-smoker. And that's the problem, because that's cross-world. But in fact, if you listen to our story, that variable is exactly our variable. Why? Because in the observed data, A equal 1 is the event O equals 1. The event A equals 0 is the event N equals 0. And by composition, and this is just the counterfactual, why give people tar but withhold the nicotine, because M of N equals 0, I can just replace by N. So what we've shown is the natural indirect effect can be re-expressed as an interventional parameter, not an intervention we can do at the moment, but I mean, we could do it at the moment, but it's going to be done in a year. And so what we're really, in a year, we could, when we have these cigarettes, we could do a 4-arm trial where, you could have both levels of N, both levels of O. And right now we have the results from 2 of those arms. The one where you always take both, and the one where you never take both. That was on the other slide. But we're interested in another arm where you take treatment. You take tar, but not nicotine. So how can we estimate it? Well, if you look at the graph, So all we're doing is we're taking the fact that we can estimate this is all based on the story. That is, the story is this graph, that it's all through nicotine. Nicotine doesn't affect Y except through M. O affects Y. We see those are exactly Caleb's counterfactuals, and our N and O's, and that means that if we can identify our parameter, it should be exactly what you get from Caleb's result, except Caleb's result needed cross-world independence. But our result is standard intervention. This is just standard stuff. We want this. So we use the G formula. What's the G formula? It's the mean of Y given its parents, where the parent tar, I'm intervening on these two guys, where the parent tar is set to the value I want to intervene on by the probability of M, given the treatment, its parent is set to the value I want it to. And then I use, okay, so that's just the G formula using independencies from parents. And then in our world, the event O equals 1 is the event you're a smoker, and the event N equals 0 in our world is A equals 0. And so I've just used the standard G formula and this determinism. And what is this? That's called the mediation formula. So from this interpretation, the mediation formula is nothing but a direct effect in this world where we divide cigarettes into the component that affects M and the component that affects Y, sometimes called a separable effect. So since these guys are equal, and we're estimating things about this, we are estimating the same parameter as Caleb. So our parameter by definition is null whenever the mediational sharp null holds, because we're estimating the same thing. Okay. Okay, that's what I just said here. This is unlike Tyler's mediation. That is our view of mediation. This is a different interventional view of mediation. That's I'm already at 1229. Okay, that there's the right view in our view because it deals with what mediation really is. It gives the same result there. And even though I was said to have invented the other kind of mediation where you flip the coin, I only discussed it to say that it wasn't real mediation. I wasn't really recommending it much. Okay, but you might say, what have we done since we just have gotten the same results as Caleb, so we've added nothing. But if the M counterfactuals don't exist, in which case Caleb's approach would not apply, our indirect effects still can be defined versus our treatment components. The only thing we were intervening on were components of treatment. Yet when his is well defined, we get the same answer. Okay, and we can also, ours is concrete. In the future, we can actually, in a year, we can actually do a randomized trial where we have in one arm people with O equal 1, N equals 0. So we're going to test in a year whether we're right about the mediation formula, because that's what it's estimating, right? It's identifying the mean of Y when we fix O to 1 and N equals 0. Not only that, but we get back no causation without manipulation. And we're not talking about crossword counterfactuals. We're not talking about weird stuff. This is just causation and the G formula. Okay, now, so the next part, I could stop if people want me to. So I'm done with that part. And these three things or two things here are, well, we can consider that a third, are advantages of our approach, but there's a lot more. And a lot more is based on what happens in the example where there's a measured confounder between M and Y in a causes that confounder, which Caleb talked about a lot. So the problem is it's 12:31. There's probably another 5 or 10 minutes. So if everyone wants me to stop, I'll stop. Take a vote.
Maybe if Thomas has something to add, we can do that. Or Jamie, you can continue for a little bit longer.
Well, so this is both me and Thomas. We made these slides together.
Yeah.
I was elected
Great.
to give it. I mean, there's nothing. He would go on with the mediator.
Go ahead, Jamie. I think we've got a little time. I think we could go on for 5 minutes. I think, you know.
Okay. So this is going to show you that in that simple situation, our intervention theory was not so different than ordinary mediation. But now we're going to show you how different it can be. Okay, so we've got this graph. So now let's do N and O. Okay, so here's our graph. We break it into N and O. Okay, now what this graph doesn't tell us is what causes L. Does N cause L, but not O? That's this graph. Does O cause L, but N doesn't? That's this graph. Or is L caused by both? So you could see the question of these becomes a different question. It's like, which of these three is the state of nature? Because these are different truths. We don't know which one is the truth. Let's say you're someone who thinks this is the truth. And I'm going to compare it to someone who thinks that's the truth. Okay, so we have this, and let's play the same game. I'm just going to do the G formula based on this graph where it's N that causes L and not O. And I just want the G formula. I want to get this. I use the G formula where it's got these O equal 1, N equals 0. But again, in our observed data, because we only have A and not A now, since O equals 1 is that event, and that event, we get identification. Similarly, we get identification for this one. It's just the probability of L in the G formula is A equal 1, because that's where that arrow is. Okay, now, whenever we get identification, our theory, you also get identification of some past specific effect, but it's no longer, so we no longer have this is true. So this is what I'm saying. This is true without the L's, but it's not true with them. Okay, so where was I? So I said there's some past specific effect. So this simple guy I got with this G formula is equal to an identified past specific effect that's written like this. Okay, this is another reason our thing's much better, because A, no doctor in the world, if you're trying to tell the doctor about mediation, could understand this. I can hardly understand it, but they could quite easily understand, I want to know what's happening in those cigarettes when I take the nicotine out. And with these more complicated graphs, even though we have L, we've identified these guys, but they're no longer equal to the to this, because in this more complicated setup, this guy doesn't map to that guy. As I mean, I'd have to go through it. Okay, now finally, let's look at what's the identifying formula for C? Well, there isn't one, because let's play the same game. Remember, graph C is this graph. We're both, okay, caused by O and an L. So I do this, that's what I want again, but I use this graph and I do the G formula. It's all the same here, except the only term is probability L, N equals 0, O equals 1. So that's the probability of L. Well, in our data, N equals 0 is non-smoker, and O equals 1 is a smoker. So it's the probability of L given you're both a non-smoker and a smoker. That's what I call not identified. There are no, that's a meaningless statement, and that's why it's not identified. Because, and L sort of in C is like what you would call a, it's not exactly, but call a, what do you call it? Something witness.
Recanting witness.
Okay. So now we're going to summarize. In the context of this graph, and A, B, and C, in none of them does this equal that. And if we know it couldn't, in A and B, it couldn't possibly, because we know this is identified by the G formula. It's only C where it wasn't. Well, we know this isn't identified. That was the whole problem that, the mean of that, the whole problem that Caleb was talking about with the L's. So for Pearl, L, no matter whether A, B, or C generated the data, it's called a recanting witness. And, you know, this is in the model where you have cross-world counterfactuals and all that business, and this is not identified. But under our model, under A and B, which are both expansions of the original graph, you know, with AM, L, and A, we do have identification of the same guy we're going to test in a randomized trial in a year when we have n equals 0 cigarettes. We're going to actually be able to compute this and see if our formula was right, or which was right. Was A, B right, B right, or we're both wrong because C was right. Okay, so they're identified, A and B, through different formulas, but they should be different formulas because one was a world in which L, only one reality is true. Either L was the only guy that affected, that N was the only guy that affected L, or O was the only guy. And under C, where they both affected L, we don't get identification. We don't know what it's going to be. Nonetheless, we're going to still learn this in a year when we do that experiment. Of course, we don't have anything to compare it with because we're not identified. So you can see once we have that L, our theory is very different and more subtle than the usual theory because we have the N and O and they can affect L in all these different ways. And so that's what's, when I said there's more good things about our theory, you really see it here. Okay, so, and here's some related work. It has to deal with, and what else? Judith Locke and Martinson and Matz. Matz has written a lot, Stanford has written a lot of other papers about this. They're all very good. Okay, so our summary, we're done, is given components N and O of treatment. So we're rather, those pass, the 1 through M, the direct one, we imagine there are some components, different components of treatment that one affects one and one affects the other. And we have these contrasts for the direct and indirect effect. And if, okay, if and only if and O only affects Y, then the contrast could correspond to direct and indirect effect. And if we have this, and this requires these counterfactuals. What would M when I tell you what nicotine to have, and this counterfactual, but we don't need any interventions. We don't need any like Y sub M, you know. So Y, when I force you to have a given level of M, those counterfactuals, unlike what Caleb was talking about, don't have to be well defined, which is good because the mediators usually, I mean, in this case is a sort of harder concept, and it's hard to know whether, a lot of people might disagree of what it means to intervene on the mediator. I think I did that already. Okay, that's good enough. I'm done. So
thank you, Jamie.
So that's the proper intervention. We call that an interventional mediation. Unfortunately, no one knows which one's being talked about. We think the other one, since it's not mediation, the one that Caleb was talking about, it'd be good to put mediation in quotes because it has nothing to do with mediation, but this one does. As you can see in the simple case, we reproduce exactly what Caleb was doing. Okay.
Great. Thank you, Jamie. Thomas, do you have anything to add?
Nope, I think that was a pretty good summary of things. I would just add this point that there isn't a free lunch here. N and O have to be real interventions because otherwise there's potential outcomes Y of N0 don't have a meaning. So it is important that one can actually, at least conceptually, think about intervening on N and O separately, and that those are subcomponents of A. So I think that's really all that I would add.
Great, thank you. Caleb? Yeah. Oh, sorry, Jamie. Go ahead.
No, go ahead.
I wanted to see if Caleb wanted to say a few words.
I stop sharing.
Oh, yeah, you can stop sharing. Yes.
Go ahead, Caleb, while I try to figure out how to get back on Zoom.
There we go.
Great. Yeah, thanks so much, Jamie and Thomas, for the really interesting discussion. Yeah, so I guess, as I said before in my talk, I've kind of presupposed that mediation is the question of primary interest, and I tried to be very precise about what I meant by mediation. So, right, and namely that mediation occurs when exposure affects mediator, and the induced change in the mediator goes on to affect the outcome. Now, you can do lots of things in causal inference that use a mediating variable that don't directly address this question of whether or not M mediates the effect of A on Y. And so I've really just kind of focused on this precisely defined interpretation of mechanism. What I think is really interesting about what the separable effects approach that Jamie and Thomas talked about is that these are interventional quantities, and on its own, this counterfactual Y of N equals something, O equals something, without reference to a DAG, doesn't necessarily have anything to do with mediation, doesn't have a mediational interpretation. It's only relative to certain DAGs that this can be connected to this nested counterfactual. And I think these have like very interesting interpretations, and perhaps even more practically useful than the effects that involve nested counterfactuals, because these correspond to actual intervention, provided that these are like meaningful decompositions, you can intervene on these components, as Thomas said, right? There's no free lunch here. But it's only with respect to certain DAGs that these connect to these nested counterfactuals, which I would argue are kind of necessary to talk about mediation in the precise form that I'm talking about, where A affects an exposure and that induced change in A affects a mediator and the induced change in that mediator goes on to affect the outcome. Because in that setup, I've kind of required the mediator to be intervenable, right? If an induced change in M goes on to affect Y, I've kind of required the M to have an intervention. So if we're saying that M can't really be intervened on, then I think we're kind of moved away from the question of mediation in this precise form and shifted to something else that involves, particular interventions, which for policy purposes, I think is maybe of greater interest. But if you're talking to a sociologist who is really just kind of intellectually curious about the role that an intermediate variable plays in transmitting this effect, I'm not sure that we might only be, I think we're only getting to that with respect to certain DAGs. That's not to say that that's a limitation. I just think it's very interesting that you start with something that doesn't necessarily have anything to do with mediation, but then you're able to show that actually under this DAG, it ends up being the same thing. Thomas, you have your hand raised.
Yeah, I don't know.
Thomas, you have 2 minutes and then we're wrapping up.
Okay. Well, I will only use 30 seconds of this, I think, which is basically was just going to say, I do think that often one of the advantages of the potential outcome framework is that is essentially helping people to formalize their questions. And I agree that nested counterfactuals are one way that can help people to formalize their questions about mediation. But at the same time, I think there are a lot of times where people have a notion of mediation, but they haven't really thought carefully about what it would be to intervene on the mediator. And so I do think that one of the things to do essentially here is that NNO can make people shift away from thinking about sort of talking about intervening on a mediator to thinking about actual policy interventions where that could be put into place, because very often with mediators, precisely because their responses, it's unclear what it would be to intervene on them. And so I think, yeah, so with your sociologist example, I guess the question is, you know, if there's a case where a sociologist can say exactly what it would be to intervene on that mediator, then we could have the discussion, we could talk about control direct effects. But, you know, quite often people talk about mediation in contexts where they don't have a well-defined intervention. Sorry.
Yeah, I completely agree.
Yeah.
And this is not at all meant to be sort of a critique of the separable effects approach. And I think, I mean, I agree with you. I think people just kind of like say, oh, we measured things intermediately, so we should do mediation without really thinking about what they want out of mediation. I think probably the most useful, like if you knew that there was an actual mediated effect, one of the most useful purposes for that information is to target future interventions, right? So if we could eliminate this path by something along this pathway, whether it be between A and M or M and Y, then, you know, then that's very valuable. But that is kind of less of a question of mediation, more a question of intervention. So yeah, it's kind of, mediation is kind of a halfway point. So I'll stop. Yeah.
Yeah. Okay, I will interrupt. Sorry about this. I really appreciate the discussion. I think it's been super interesting. So let me just wrap up for everyone who needs to leave at a certain time, and apologies for running over time again. So next week, we'll have a talk by Rochi Yu from UIUC on how to learn more from observational factorial studies. So hope you all join us for that. Thank you for your attention and for staying here a little longer today, and see you next week. All right.